infinite geometric sequences or series. We had talked about two types of series, one where a series is convergent versus divergent. So given the following example, decide whether each infinite geometric series is convergent or divergent, and then find the sum of the series if it exists. So looking at our sequence of A, we are given 1 minus 1/3 plus 1/9 minus ... meaning this sequence is going to go on forever. It is never ending. Okay, so looking at this sequence, I can look at my sequence and recognize that my common ratio would be a negative 1/3. So because my ratio falls within this range, it's greater than -1 but smaller than a +1, I can tell from this sequence that this sequence is convergent. And when a sequence is convergent, that means it approaches a fixed sum. So to find that sum, we use the formula for an infinite series, the first term divided by 1 minus the common ratio. So I'm going to substitute that information in. My first term is 1. I'm going to divide this by 1 minus a negative 1/3 is my common ratio. Let's rewrite that. So the sum of this series, if I divide these values, if you want to do it all in one step, make sure you put this bottom values in brackets on your calculator. 1 divided by 1 minus a negative 1/3, and this has a sum of 0.75. Okay, so if I were to continue to add these terms forever and ever and ever, this sum is going to approach the value of 0.75. Looking at example B here, my sequence is 2, -4, plus 8, minus ... So again, this sequence is going on forever. It's an infinite geometric sequence. Looking at this, I can figure out my common ratio is a -2. So because this ratio is outside of this range, this tells me that this sequence is a divergent sequence or series. And when it is divergent, this means as I continue to progress in this sequence, the sum of this sequence is going to be undefined or cannot be found. It does not approach a fixed amount. The sum would be essentially infinite.